So now I would like to invite the next presenter, Jesus from Voltera, to join me on the stage. He'll be telling us about multi-layer flexible displays using electroluminescent ink.
Good morning, everyone. My name is Jesus Zozaya, and I am the CEO and co-founder of Voltera. Today, I wanted to share a fun little project that our applications team worked on a few months ago. This project really stress-tested our products and pushed us to overcome a number of completely different obstacles, and at the end of the day, it ended up improving our underlying technology. So you can, based on the titles slide, you can get a hint of what that project was. But before I jump into the project, I want to talk a little bit about Voltera. So I'll give you a bit of a brief overview. So we are a Canadian company located just outside Toronto, about an hour away. Or as we learned yesterday, it's about a 10.5-hour drive, not a 9.5-hour drive, as Google Maps would indicate. But for the last 10 years, we've been helping engineers, product developers, and researchers prototype their ideas. Our tools enable them to go from concept to creation in a matter of hours, not weeks. We have two products on the market. The one on the left there is the V1. It's a compact tool. It's small. It's about the size of a laptop that can print conductive ink and reflow solder paste to prototype rigid circuit boards. Nova, one on the right, is a dispensing system compatible with any screen printable material for non-traditional flexible hybrid electronics. And the key thing that they have in common is that both of them use direct write technology. And that's going to be a common theme in the presentation here. All right, where were we? Back to the project. So it all started when we stumbled on Saralon. Is anybody from Saralon here? One person's hand. It's probably Steve. Is that you, Steve? There you go. So we stumbled on Saralon, and we discovered their suite of electroluminescent inks, which caught our eye, not because they're bright and shiny, but because they are it's a unique application for displays and smart packaging, and it's something that our customers have been asking about. So a quick primer on electroluminescent displays. They are a cost-effective, single-color displays that can be printed entirely additively, adding layers, on substrates like paper, PET, or glass. And they're created by stacking those different functional materials. So this concept is pretty familiar for those with screen printing, because screen printing, that's kind of easy peasy, right? But we didn't know if it was possible to do that with a direct write approach. And that was a challenge laid ahead of us, so we embarked on a journey to produce our own electroluminescent display using our materials dispensing system, Nova. So right from the start, we knew it was going to be a bit of a challenge for a number of reasons. First off, the project required stacking 4 distinct materials on top of each other. So the images here are the actual layers that were printed. So at the very bottom where it says layer 1, Sarol Silver 700, that's the one that goes in contact with the substrate. And then you kind of build up layer 2, layer 3, and eventually layer 4. One thing to note is that each layer is kind of unique and has a different, like a unique design, different artwork. And each layer needs to be properly cured in an oven before the next layer is added. So that means we can't necessarily do kind of print. It needs to be print, cure, but during the curing process, you have to take it out, bring it back in. So we need to get like really perfect alignment for every single layer. Another challenge was that the two materials, the conductive polymer and phosphor, were completely new to us. They behaved a little bit different than what we were used to. So big thanks to Saralon for providing lots of tips and guidance on how to work with these materials properly. The last major challenge was the software. So when we released Nova, the Nova was really designed to do kind of single layer printing, one layer at a time, on a mostly flat surface. Multi-layer printing, the surface immediately becomes very irregular, obviously, as you dispense one layer. Now you have to, now your flat is not really flat. So it's kind of riddled with discrete jumps. So generally speaking, for those that don't know, in direct write printing, the nozzle tends to hover over the surface at a distance of around 40 to 100 microns. So any changes in elevation, no matter how small they seem, can really make a dent in your print quality. So to address these issues, we needed to get creative and do a lot